My name is Mike Boyle, and this is my MEMS 5001 project final report. The goal of this project is to optimize one's visit to the St. Louis Zoo using a traveling salesman problem to find the optimal route and a knapsack model to eliminate any stops that take too long with your predetermined time limit for the day. There are 43 total stops to make throughout the zoo, featuring a cadre of different animals and exhibits for children and family alike. A few of the more interesting ones are shown at the bottom. The Somali wild ass is sure to be a hit among the children. The Living World contains a restaurant, gift shop, and many learning experiences, and the Lakeside Cafe is a large restaurant located in the center of the zoo. These are probably going to be must hits, especially if you have little kids with you, because they're going to want to take breaks. They're going to want to hit the gift shop and look at all the toys. They're going to want to have a lunch break or dinner, depending on what time you're there. Stops are plotted on the right, as according to the map on the left. Not every individual plot is one single animal. Some of them feature multiple animals at the same spot if they share an exhibit or they're right next to each other, but times are accounted for as individual animals, not individual points. Initially, without optimization, the sub-tours are shown on the left. There are 9 total versus the right, with one continuous route that follows the walking paths nice and conveniently throughout the zoo. Nothing as the crow flies. Assumptions made include time at each stop depends on the type of the stop, so individual animals have a little bit of time, large exhibits have a little more time, shows have the most time. The walking time and kid-related time, such as tantrums, breaks, and snacks, are built into the time at each stop, so there's not separate constraints for those. It's just a bulk assumption for the sake of convenience. Any show time is assumed to be available as needed. You don't have to make reservations ahead of time. Only one continuous tour is allowed, and the zoogoer will spend a maximum of 5 hours at the zoo, so your stops will be ranked based on a goer's preference and then filtered by time with the knapsack problem. And considerations include visiting all the stops is not possible with the current time estimates based on the 5-hour time limit, and stop rankings based on user preference. Results are shown in the table to the right. Stops are ranked from 1 to 10, with 10 being the highest. The maximum time allowed is 5 hours. And the furthest right column, a 1 denotes staying and visiting the spot, and a 0 denotes skipping the stop. So something important to note is that if a stop is deemed skippable, it's still included in the route because the route follows the walking path and is the optimal course to take. So even if you decide to skip one, odds are you'll still have to pass it on the optimal route. So it doesn't need to be removed. You just don't stop and spend time at it. Future work includes adding dynamic constraints based on the time at each stop, so you can make sure you get to every stop. So instead of saying there's a bulk time for all stops, you would tweak it so you could make sure you saw everything. Change the optimization process to include wait times at different shows and scheduling based on busyness. And then an interesting one would be incorporating the zoo train as either one of 2 options: a timed activity that goes to the same start and stop point, or a method of traveling across the zoo which would affect your time or your optimal route. Thank you.